Hey folks, today I'm diving into the fascinating world of thermal imaging. You ever wonder how those cool thermal cameras in movies actually work? Well, stick around because I'm going to unlock the secrets and show you how to build one yourself. First off, let's break down the basics. A thermal imager detects infrared radiation, which is basically heat. Everything emits some level of infrared radiation, and the hotter something is, the more it emits. These cameras capture that radiation and convert it into an image we can see. The result? A colorful display of heat. So what's behind the magic curtain? At the core of any thermal imager is a sensor called a microbolometer. This sensor is made up of tiny pixels that change resistance with temperature. When infrared radiation hits these pixels, it causes a change in electrical resistance, which can be measured and translated into an image. Cool, right? Now, on to the DIY part. Building your own thermal imager might sound daunting, but I've got you covered. Here's what you'll need. A Raspberry Pi, a thermal sensor like the AMG 8833, a camera module, and some coding skills. First, grab your Raspberry Pi and set it up with the latest operating system. Make sure you've got Python installed because we'll need it for coding. Next, connect your AMG 8833 thermal sensor to the Raspberry Pi. This sensor can detect temperatures from -20 to 80 degrees Celsius and has an 8x8 grid of thermal pixels. Perfect for our DIY project. Now, hook up the camera module. This will allow you to overlay the thermal image onto a visible light image, giving you a composite view of both heat and the actual object. Alright, time to code. Open up your favorite Python IDE and install the necessary libraries like Adafruit _AMG88XX and Pillow for image processing. Write a script to read data from the thermal sensor, convert it into an image, and then overlay it onto the camera feed. Once your script is ready, run it on the Raspberry Pi, and voila! You've got yourself a homemade thermal imager. It might not be as sophisticated as commercial models, but it's a great way to understand the technology and have some fun experimenting. If you enjoyed this deep dive into thermal imaging and want more tech DIY guides, make sure to hit the subscribe button and give this video a thumbs up. Stay curious, folks, and keep tinkering. Until next time, peace out.